Our last speaker is Yochai Yemini. Like we had really interesting lectures. All of them were more related to vision. And this last lecture combines vision and voice. I think it's very interesting. And Yochai Yemini, he is a PhD student in Ilan University, and also deep learning researcher in OriginAI. And Yochai is going to speak about lip voicer, generating speech from silent videos guided by lip reading. Thank you.
Hi. Hi, everyone. Thank you for having me. I'll be presenting our recent project called Lip Voicer, and which we will also present next month at iClear. So let's start by the problem definition, which is rather simple. We address the lip-to-speech problem, in which we are given a soundless video of a person talking, and we would like to generate the missing speech as accurately as possible. So in general, the input in the lip-to-speech task looks like this, right? And it can happen, for example, if we take a video of a person talking and there is so much noise around us that it completely masks the target speech. Now let's talk about the challenges and the requirements that we have from the generated speech. We would like it to be intelligible, to sound natural. Of course, we would like it to be synchronized with lip motion, and also we would like it to reflect the identity of the person in the video. For example, if it's a mid-aged woman, we don't want her to sound like a 15-year-old boy. And the last challenge is that, unfortunately, we have ambiguities in a given lip motion sequence. Like, for example, if I say ba or pa, it may look the same to you if you can't hear what I'm saying. So now that we understand some of the challenges, let's talk about what we did in Lip Voicer. So in our method, we have three main components. The first one is called MELGen, simply because its job is to generate MEL spectrograms, which is a time frequency representation for speech, which is also used in text-to-speech, for example. And it is a diffusion model. The other two components are a pre-trained lip reading network, and the last one is an ASR system. And the important thing to note about it is that the only model that you train is actually MELGen, and the other two components are used during inference time only. Now let's elaborate now on MELGen, the first component. So it has two main objectives. The first one is to make sure that the voice in the generated speech matches the identity of the person. And since we know that what a person looks like has a connection with what he sounds, so what we do, we randomly pick a face image from the video and take it as an input. The second thing we would like to achieve is to transfer the dynamic information from the video to the generated speech. For example, it could be when speech starts, when it ends, intonation that you have, and we can get that from if we focus on the lip region in the video. So we take a crop of the lip region and have it as an input, and we extract features from the face image and the lip region video. We combine them and we use them to train a diffusion model guided with classifier free guidance. And after we train this model, it knows to predict the diffusion noise, and this way we can generate MEL spectrogram. Now, let's just for a second say, okay, perhaps this MELGen diffusion model can do. We can only use that one to generate MEL spectrograms. So let's see what happens. Do you remember this lady? So let's hear what she sounds like.
Researcher to the contract from a waster couplet for.
Okay, so it sounds like very great audio, but she speaks like perfect gibberish, right? And so the challenge now is how to make her say like valid words. And the reason that she speaks gibberish is because of the lip motion ambiguity that we talked about. How we do it in lip voicer, we address it only during inference time. So you remember those two components that I talked about. The first one is a lip reader. So the nice thing about lip reader is that it can give us a prediction of the transcription of what is said in the silent video. So for example, if this woman here in the picture said Ivy League degree and a Wall Street job, that's hopefully what the transcription is going to be. But the question now is how to make sure that the generated speech will represent the words that given by the transcription. So a nice way to do that is using classifier guidance on top of the diffusion model. So our classifier is going to be an ASR. So now when the Melton block at each time diffusion step, it's going to generate an intermediate male spectrogram, and then the ASR is going to say, okay, this is a good one, it matches the words or not. Okay, so now let's see what the generated speech sounds like now.
And one activist actually found a contract from a Western company for sale of surveillance.
And one activist actually found a contract from a Western company for the sale of surveillance.
I think it resembles very well. And this is one of the baselines.
And one activist actually got a contract from a Western company for sale of surveillance.
Okay, so generally speaking, over the baselines sound like this. So I have another example.
Giving hope and care to others is something our armed forces do, without question.
Okay, so now let's move on to talk about some quantitative results. So we conducted human listening tests, and you can see it's basically numbers. You can see that we achieve good numbers compared to the ground truth and the baselines. And also, you can see that we significantly reduced the word error rate. And one last ablation study I would like to show you is that if we use a more accurate lip reader, we can also improve the quality of the generated speech. For example, if we take the ground truth text, we can achieve a word error rate of about 5%, and other metrics are less important now. But yeah, thank you. If there are any questions.